Okay, so here we're asked to factor a trinomial, 15x squared minus 4x minus 4. Now, as with any initial stab at a factorization problem, the first thing you should probably do is just check to see if there's any greatest common factor you can take out of all the terms that you see. And as you can see with this one, no such luck. Nothing non-trivial is going to come out anyway. There's no meaningful number you can simultaneously take out of 15 and 4, and not all the terms have x in them, so you can't take an x out of everything. So here's where you can just kind of go right past the failed GCF approach and now try to factor this down using some sort of trinomial technique, since it is exactly a trinomial. So this trinomial's leading coefficient isn't 1, so I might try the multiplicative technique on this. So you got a leading 15 here and a constant minus 4. So 15 times minus 4 gets you minus 60. So you can take this trinomial setup and bump it up to a groupable 4-term polynomial setup if now you can find factors of that minus 60 that combine to that minus 4 in the middle. And there are such factors. In either order, the factors of minus 60 that combine to this minus 4 are minus 10 and plus 6. So you can rewrite that minus 4x in the middle in either order as minus 10x plus 6x, and you can see now that that decomposition of the minus 4x in the middle as a minus 10x plus 6x essentially recreates the outer and inner products from the FOIL, so that you end up generating now an equivalent 4-term setup that you can fully factor by grouping. So here I've cordoned off the two little groups, and now I'm going to attempt greatest common factorizations on each little group to fully factor these down. So here we've got a 15x squared minus 10x in the first little group, so I can take a 5x as a greatest common factor out of that first little group alone, and that leaves a 3x minus a 2. And now I'll know that this decomposition, this reconstruction of the outer and inner products from a FOIL, has been successful if I can take something out of the second little group such that the leftover piece matches exactly this 3x minus 2. So here, the thing I can take simultaneously out of 6x and minus 4 as a greatest common factor is 2. So I take this plus 2 out, and that leaves behind 3x minus 2, and that's exactly what we needed to have happen. The grouping has been successful. We've got exactly the same leftover binomial piece here of 3x minus 2, so by grouping we can finish it off by factoring out the common 3x minus 2 and then just writing out the binomial leftover here. You've got 5x left behind from the first term and plus 2 left behind from the second. And if you were to FOIL this out, you get exactly that 15x squared at the beginning. There's the minus 10x inner product and 6x outer product that we decomposed here in setting this thing up as a groupable factorization. And then there's minus 2 times 2 gets you the minus 4 at the end. So there it is. There's your fully factored final result for this particular case, 3x minus 2 times 5x plus 2. And this is certainly something that you could get just by observing and playing with factors of 15 and factors of minus 4 until you found some kind of binomial combination of them that foiled out to exactly 15x squared minus 4x minus 4. But this multiplicative approach can save a lot of that guesswork. Take the leading times the constant coefficient, multiply them together, see what factors of that product combine to the coefficient of x in the middle, and use that to decompose that middle term so that you get a nice groupable approach that leads pretty quickly to your final result.